suppose I should put on my microphone. I mean, you don't actually have to hear me, right? In some of my upper level classes, it's really fun to shut off the microphone and have people guess what I'm saying. I am that kind of teacher. All right, well, welcome to EGR 210. My name is Dr. Cale Stoley. I am a professor of physics and engineering here at Doane University. If you do know me, I'm sorry. If you don't know me, I'm the greatest professor in the world, and this is going to be a great semester. Oh, hey, Luke. Nice to see you. It's been a while. I don't have to apologize to Luke. You knew what you were getting into. In any case, the purpose of this class is to teach fundamental ideology behind engineering design. Engineering design is itself fairly complex. If you took EGR or PHY 101 with me, you know that we talked about the engineering design process. We covered it very briefly. For some of us, that was 4 weeks, 5 weeks. I think I gave to everybody 4 or 5 weeks as compared to a full 15 weeks. We're really going to dive in deep into what engineering is. Engineering is part business, part management, part leadership, part teamwork, part modeling, it is many things all in one. And we're going to try to cover that in this class. Now, this is a fairly entry-level course. We're not going to be doing math in this class. For some of you, that's a boo. For some of you, that's a yes. But we're not going to be doing calculus for this class. Calculus is not a prerequisite. We're going to focus more instead on the fundamental ideology of what engineering design is. Yeah, if you don't know who I am, this is my 4th year at Doane. Many of you, this is what my face looks like. Believe it or not, some of you don't know me by face, because you've seen me teach with a mask all year. That's horrible. It makes me sad to think that that's your reality, that you don't even know what your professor looks like. Yeah, this is me. You know what my voice sounds like, at least. Hopefully I sound like the same person. You never know. I mean, the camera adds like 10 pounds to your voice, so my voice is huge. It's all beef. I don't even know what that means. Okay, so the way that I set up my classes, this class is going to be a hybrid class. Part of my reason for that is because the class is large. Also, part of my reason for that is I traditionally have taught this class where I've had a very long, lengthy lecture for one class, and then the other class was you show up and we work together, we solve problems, we work on projects. The more I thought about that, the more I realized that's really dumb, because why would you come sit in class while I regurgitate information to you for a long time? I have been wanting to post YouTube videos for this class for years. And this is really my first chance where I kind of have to do that. And what I will do is I'm going to post videos, 1 to 2, maybe 3 videos if I'm having a really good week. Every week I will post, and those videos will discuss the engineering design process. It's going to follow the syllabus, which has been posted on Canvas. We're going to go over that syllabus today. But the videos are going to cover the engineering design, the theory, the elements of success. Now, the reading assignments will also complement the lectures. and the reading assignments and lectures together will be material that goes into the quizzes. So you're going to take a quiz and it's going to be over the engineering design theory process, different components that we talk about in class. On the other side, aside from the quizzes and the reading assignments and the lectures, we're going to be working on projects and learning modeling. Modeling is, we're going to be working with AutoCAD and SolidWorks this semester. The goal of learning modeling is that any engineer has to be able to visualize a solution. Any solution that is real is able to be drawn. And I know that sounds weird, but that's true. You can draw anything. It doesn't have to be drawn well. Sometimes you can draw a really terrible drawing, and that's all it takes. But you have to be able to model it visually if you ever hope to model it physically. So a physical solution, whether that be building a computer, whether that be building an embankment for a drainage system, whether that be designing a road grade, you have to be able to model it some way so that there's a visual model for somebody to look at. Visual models are distinctly different from mathematical models. They're distinctly different from prototypes. All three have their merits. We'll talk about this a little bit more in the semester, but we extensively cover modeling in this class because modeling is a really powerful tool. For those of you who are looking at going into civil engineering or mechanical engineering, the SolidWorks modeling that we use in this class is fundamental to teaching finite element analysis. Finite element analysis is basically a way for a computer to do a lot of math for you, and it's really, really a lot of math. But finite element analysis is something that it's a program that a lot of high-level engineers will use to analyze a structure, analyze a component, analyze a transmission mechanism. So understanding modeling is critical for those. For an environmental engineer, if you're working on a layout, having to be able to draw out a layout is really critical. The feedback that we have gotten from our industry partners about engineering is that a lot of students do not understand how to appropriately model something. And that's kind of sad, because if you're saying, here's a solution, it's a physical solution, here's a solution, and I do not know how to give that to you, I do not know how to communicate that to you, that's kind of it's not doing a service, both to the student or to the, well, really to the employer. So the goal here is we try to encourage the full engineering process. To do that, we're going to have 2 semester-long projects. One of them is going to correspond with our unit on AutoCAD, and one of them is going to correspond with our unit in SolidWorks. Both units are going to require substantial research, understanding, that sort of thing, so that we can come to a good knowledge of what we're doing, because that is also part of the engineering design process. Engineering design can be really fun. But it can also be really terrifying if you do not know what you're doing. So we will cover all of that material, and we'll do it as best as we can. Now I'm just saying words for the sake of saying words. Words! Words! All right. Let me pop up my screen so that you can look at the syllabus with me, and we will jump through that. So, here's the syllabus. It's got words on it. This syllabus has been posted on Canvas. So here's the name of the class. It's EGR 210, Fundamentals of Engineering Design. This is my name. This is my office. This is also my name. This is the school that I work at. This is a .edu suffix. This is my office phone number. I have not posted office hours yet. I'm still waiting on one more appointment before I definitively say, here's when I'm going to be in my office. Also, I really struggle with sitting down for long periods of time, so it's if you're going to go into my office hours, please let me know so that I will make sure that I'm not getting up and running around the hallways because I have ADHD. You can always email me at any time. There is no stupid questions. If a question is something enough that it peruses you, and it's not inappropriate, you do need to say that, feel free to throw it at me. I will gladly take any of your questions. We do have a textbook for this course. This is the point where I get up and walk away. I'm grabbing the textbook. So, also I'm off camera. I'm fighting a sea monster. I get to do whatever I want off camera. It's left to your imagination. This is what the textbook looks like. I believe last I checked, this costs like $50, costs like $20 on resale. It's a nice book. It covers the entirety of the engineering design process really well. David Ullman is a well-known author. The guy owns his own publishing company now because he's a well-known author. And also, other materials is having a laptop with a Windows operating system. We are going to be working in AutoCAD and we are going to be working in SOLIDWORKS this semester. Both of those programs run better on Windows. In fact, you can't run SOLIDWORKS on a Mac. It's unfortunate, but quite frankly, excuse me, I'm dying. I'll find another professor to teach this class if I expire. What was I even saying? Right. Windows is just, it's a more common language for scientists. Back in the 1990s, Mac and Windows were competing for client bases. Windows ended up winning the scientific community, and Mac ended up winning the artistic community. So, made for a major separation. It's a whole, I don't want to go into it. Course overview, you can go ahead and read this on your own because again it's posted, but the idea is that we're looking at product development, problem discussion, analysis of problems. How do you know an engineering solution is viable? How do you know that it's good? How do you know it's the best? In order to, ooh, that was a burp. In order to best understand, recognize the solution, you always have to be able to understand what the competition is. You have to understand what the population needs are. I really love showing videos of people who are absolutely awful at producing engineering designs because there's a lot to learn from that. Simply designing something does not mean there is a market for it. I like to use the example of the Sega Game Gear. Sega Game Gear came out in the 1990s. Amazing piece of technology. Batteries like nothing else. You couldn't go on a car trip without having a 12-pack of AA's. And even then, good luck. Game Gears were just phenomenal. They had color screens. Games were very high quality. But the Sega Game Gear, despite being a step up in technology, ultimately failed. Go look at the PlayStation Vita. PlayStation Vita preceded the Switch by like 6 years, something like that. It was a piece of technology that was very, very powerful, very strong, best handheld console at the time. That also ultimately failed. Whereas you go look at the Switch, Nintendo Switch, is still friggin' sold out. I tried to buy some for my nephews for Christmas, and it's like, I can't find one. I digress. Just because something is good technology does not mean it will sell well. It does not mean it will be well received. It can be great technology, and there's no market for it. So, how do you, as an engineer or as somebody assisting with an engineering design project, how do you justify something? It's something that keeps a lot of engineers awake at night, because engineers sometimes will be allocating funding towards millions of dollars. And how do you make those decisions and feel comfortable with yourself? It's terrifying. Well, we're going to talk about that in this class, and we're going to try to build some confidence. One of the reasons why I like doing projects for this class is because it does help build confidence. How do you stand in front of somebody and say, hey, use my product, when quite frankly, you don't know if your product's any good? Well, I teach you how to think. How do you understand whether or not something is good? So there's a lot of other stuff in the syllabus I have to include, but this is the next important part. What I'm expecting out of you for this class, I'm expecting you to be able to construct and assess basic 2D and 3D diagrams, parts, structures, assemblies. Okay, that is all included as a part of the second module, which is being able to produce professional deliverables. This includes design displays and assessment reviews. How do you assess technology professionally? And how do you display that information? You will be able to critically evaluate existing and proposed technology. You're going to be able to establish design plans for development of products. I mean, this is the foundations of what engineering are. Now, this class is going to be taught in hybrid mode. As I said, rather than forcing you to sit down in class one day and just listen to me talk forever, you can watch it on YouTube in your own world. We will meet once a week. I will email you with who is going to be showing up on which days. Yes. Okay. So that makes sense. Students in the Tuesday section will show up on Tuesday. Students in the Thursday section will show up on Thursday. If you're in the Tuesday section and you don't show up on Tuesdays, you're going to need to be in communication with your group, because we're going to be doing group projects. And the purpose of showing up to class is to work as a part of a group. So if you're stuck in quarantine or something like that, be sure to communicate with your group so that your group is aware of what's going on. Okay, 2 online lectures, that number is fluid. That could be 3. Or if I'm feeling really ambitious, it could be 4. It depends on how much information I feel like you need to get. Some of that information may be related to modeling, such as AutoCAD, SolidWorks. Some of that may just be a quick 15-minute lecture on, I just used the word quick in 15 minutes. I tend to be very wordy. You will be expected to complete modeling assignments every week. I don't think that's in here. Yep, I forgot. Nope, they're in here. You will be expected to do textbook reading, okay? Everybody picking up this textbook. Your first reading will be due in 2 weeks. Your second reading will also be due in 2 weeks. The idea is that I would wish that your first reading would be done by next week, but some students don't have their textbooks yet. So I give you a grace period of a week, but I assign a second homework assignment. So if you want to wait till the last minute to complete both of the reading assignments, knock yourself out. Not physically, though. But I will be assigning both of those as soon as I can, so that you are aware of what is upcoming. If you want to work a little bit ahead of the class. If you are a student who is in sports this semester, it's always good to work ahead because you don't want to be behind. I will do my best to try to give you advance notice on everything that's due. It is your prerogative to make sure that I am aware when you will miss class, but also to talk to your groups. And as long as your group is happy, that makes me happy. If your group is unhappy with you, your grade will reflect it. Because we do student reviews as a part of the project. So, teamwork is a very valuable part of any engineering team. If you cannot work as a part of a team, it does make everything harder. Here's my grading percentages. Here's my grading scale. This is the preliminary schedule for the semester. We'll be talking about course discussion, form function, design teams, design process, design selection, design planning, proposals, house of quality, Pew matrices, decision making, tolerance, performance, design considerations. We'll do a quick review on the other side. So those are all going to be stuff that I send you videos over. On the other side, this is going to be stuff that you have modeling learning assignments over, and I might post an occasional video over just detailing it. I believe on Thursday, one of my lectures will be how to download AutoCAD. So, or maybe even what AutoCAD is. I hope so anyways. Pretty sure I need to make sure that's planned that way. But this is what the semester looks like. So I know we have 3 weird off days this semester. I will assign lighter homework those weeks if I remember. I will try to assign lighter homework those weeks just because it's supposed to be a day off. But you might need to remind me because it's really easy to just keep going on the train. I have a lot of expectations for you as a class. This should be a developmental class. Final for this class is going to be presentations. I like giving presentations. We do have presentations early on in March for Project 1 as well. For both of those classes, I will expect you to dress up because you cannot give a presentation without looking nice. So, you will need to make sure that sometime in the next 2 months you acquire a set of professional clothing. I don't care if you borrow them from a roommate. I don't care if you ask your parents to send them through the mail to you. If you absolutely need help buying them, you can always talk to me. I can send you with $20 down to Walmart. I think I got this shirt from Walmart. I got these pants from Walmart. I got these shoes from Walmart. Everything I'm wearing it costs less than about $50. I really should admit these things. But you can be a thrifty professional on a budget. I've had to do it myself. All right. If you have any questions about this, feel free to throw that up on the YouTube chat. I do have a few more things to say before I finish this branch. What you will need to do to see my next YouTube lecture is you will actually need to go back into Canvas and click on Lecture 2. So as soon as this video is over, which I'm going to try to get it done with in the next few minutes, you will need to jump on there. So one of the nice things about live streaming is you can throw your message out there and let everybody see it. I will try to see it and address it when I see it. Yeah, YouTube. I hate Zoom. I hate Zoom. I use Zoom. I hate Zoom. I will use YouTube as much as I possibly can because I prefer YouTube. Quality of YouTube is better. Plus, you can always go back and rewatch this video whenever you want. That is a benefit. So if you feel like you missed something, you got sick during the middle of a video because I was talking and you had to listen to my voice, you will need to come back and throw up again. I can feel your bulimia. Oh, that's a terrible thing to say. I post these things on the internet. If I get fired, it's because I just say whatever comes to my mind. It just pops out my mouth. Okay. Before I end this part of the video, the course introduction, if you are currently in my class and you are not in Physics 201, you should be. If you're going for an engineering major, you need to figure that out. Please contact me right away. We need to set that up. I want everybody to be successful, and if you don't take Physics 1 this year, you will be a year behind in engineering. And it's not fun playing catch up, and it's not fun having an extra semester. It's very hard to not take Physics your first year. and then graduate in 4 years. In fact, we have not had anybody do that yet. So, if you're not in Physics 1 right now, let me know. I will work with you personally. That was another burp. I've heard you can actually hear it really well on the microphone. I should not drink sodas before class. And Luke, that doesn't count. You have to go take Physics 1 again. Sorry. I know it's a little bit under your level, but... Okay, so go back to Canvas, go back to Modules, click on Lecture 2. I will see you there in about 5 minutes. I gotta set up my camera so that you can look at me on the whiteboard. Okay? All right, I will see you in 5 minutes. If you need to, go see a man about a wallaby.